Hello and welcome to video 1B. In this video, we're going to work a little bit more with angles. We're going to start off with something I think you know, so I'm just going to write it down really quickly, and that's how to classify angles. Angles can be classified as one of four types. We can have what we call an acute angle, a cute little angle, which is always an angle that measures less than 90 degrees. Remember, your 90-degree angle looks like this. So an acute angle is any angle that is less than that or has its terminating ray in there somewhere. And a right angle, I just told you. We can classify an angle as a right angle if it meets at a 90-degree angle. This is either told to you, it'll say the angle is 90 degrees, or it'll say that line L is perpendicular to line M, so you'll know with the word perpendicular. Most of the time you get the little box in here that indicates that you have a right angle. So exactly 90 degrees. And then we have in our obtuse or our obese angle, those are ones that are cracked open more than 90 degrees. And our last kind we call the straight angle. And a straight angle is exactly that. It's completely straight. It doesn't even look like an angle. It looks like a line. And its measure is 180 degrees. Exactly. So there is an angle on here. If I were to put this here, call it A, this here, call it C, and this here, and call it B, the angle is CAB. And I'd be done. And it's a straight angle because it's 180 degrees. 180 this way, more than 90 this way, exactly 90 this way, and less than 90 that way. So you need to identify them from their pictures and from their angle measures. The next thing you're going to be doing is naming angles. Before we do that, I'm going to take care of a little bit of vocabulary. When you're asked to name a vertex is a single point, and you name it using a single letter. So your answer should be just a single letter. On this one right here, the vertex is right here where the two rays meet, and we name it, we say the vertex is just letter T. So just a letter means the vertex. It doesn't mean the angle. We'll talk about that over here. But the vertex is where the two rays meet. It's the starting point of both rays that make the angle, and we name it with just the letter. The sides are rays. There's always two sides to an angle. So you should give me your answer as 2 rays. On this one down here, if I were to name the sides, I have ray TS, and again, I can't just go like that. It's wrong. And I can't put ST. I have to start at the vertex for a ray and head forever through S and use the proper notation. One of the biggest problems with people when they do geometry is their notation. Like they'll say, name this angle, and people say, oh, it's angle T. No, T is the letter, it's the vertex, it's a dot. The sides, and people say, oh, it's side TS. No, it's a ray from T to S. So the other side over here is the ray that goes from T to U. So proper notation is necessary. When you name an angle, you can name it multiple ways. So we're going to name this angle right here 4 ways. First of all, on a little aside in green, which you don't need to write in your notes, when two angles share a vertex, we call them adjacent. And when we have multiple angles in at the same vertex, we have to be really careful with how we name them. Because if I just say the name of the angle is angle B, you don't know whether I'm talking about the top one, the bottom one, or the whole one, because they all share the same vertex. So in this scenario, I only have two ways to name a particular angle. If I want to name this angle right here, let's go do it in red here, this bottom one, I only have two ways of naming it. I have to use three letters so that the person looking at it knows exactly which of the three up there I want. Do you want the top one, the bottom one, or the big one? And I'm saying I want you to name the bottom one. Then you have to put the vertex in the middle. So I want you to go over here, vertex in the middle. And then you hug it with both the sides. And I want you to stop and look at what I wrote because it's not right. Again, I told you you have to be very, very careful in geometry with your notation. Three letters listed consecutively like that is the notation for a plane. Angles require this in front of it. So although I'm going to name my angle four ways, because I'm naming it, I have to put the angle symbol in front of it. So I can call that one angle DBA, or I could call it ABD. It doesn't matter. So back to the one you need to write down here. The four ways I can name this is using, wanted this to go back to blue. Come on, blue. All right, so I can name it with the three letters. I could say that's angle, and I take the top letter, which I just wrote over, J. I always have to put the vertex in the middle. That's one name. Or I can call it angle H, I, J with the vertex in the middle. Or because this is numbered, I can call it angle 3. Or because it's not shared by another angle, there's no other angle emanating out from letter I can actually call it angle I, and the user would be 100% sure what angle I'm talking about. But all of the names need to have this angle in front of them when you're naming it. So let's go take a look at this one. This says name all the angles that have V at the vertex. So I'm not going to name all of them, but I'm going to name a lot of them. I could say angle 3 does. I could say angle 4 does. I could say angle 5 does. I could say angle the whole big one, CVF. Or I could say FVC, that's the same one. If I said this one in here, that's angle 5, and that's being redundant. So how about if we talk about this top one right here, angle DVF? Or maybe I could do this one right here, angle CVE. So there's some angles that all have the exact same V as its vertex. When they ask you to list a point interior to an angle, that just means inside of it. So right here, if I call that point W, I would say W is interior point. Exterior is just outside of the angle. Let's call that Q. I'd say angle Q is an exterior angle. That's pretty self-explanatory. So next up on this video, the angle addition postulate, which we sometimes call the AAP. So this says to draw angle ABC. That means I have to have B be the vertex. I can draw any angle I want, but I have to emanate out through A and somewhere else through C. That's angle ABC. B at the vertex. It says put ray BD on the interior. So inside of there, emanating out from B, and you might say, hey, you didn't put the symbol on top of that. I didn't need to because I put the word in front of it. So without the word in front of it though, if I said just BD, that means how long it is. So again, I'm going to repeat that over here. This is how long it is from B to D. It's a number. This is the segment connecting B and D. Looks like this, B and D. This is the ray, B to D. This is the line, B to D. All right? So you might say, but over here, again, you did this one, so isn't that the length? I covered the symbol with a word, so I'm good to go. BD is supposed to go out into the interior. What the angle addition postulate says is that from here to here, and that would be angle A, B, D, but because I'm going to be talking about its measure, like it looks like it's about 30 degrees or 40 degrees, you have to put the M in front of it for the measure. Without the M, it's the picture. If I just say angle ABD, I'm just talking about this picture. M means its measure, so be aware of that. Plus, if I were to measure the angle from D to B to C, the angle addition postulate says that's got to be equal to the big angle from A to B to C. So really what that says is if you're 30 and you're 100, you're 130. So let's go see what kind of problems you'll have with that. So here's a couple examples. Example number 1 up here. It says find the measure of IHQ. It's important that you go get a visual for that. IHQ is the whole big one. From I to H to Q. Oh, it's not. Sorry, it's that little one up on the top. Good thing I went and looked. I'm looking for what's the measure of that little angle in there. Okay, I'm going to go put a little arc in there. I don't know. That's going to be my answer. And then they tell me the measure of IHG. That's this whole angle all the way across is 176 degrees. QHG, this one right here, is 130. So whatever that one I want is, plus the 130 has to equal the entire way, which is 176. So really I'm just going to subtract 130 from 176, and I get a nice 46 is the answer. And then throwing in a little algebra, it doesn't change the concept, it only changes the difficulty in executing your answer. So my goal is to find x. I like to box in what I'm looking for. Then it tells me some stuff. It tells me the measure from L to M to N. That's the whole big angle. So they're telling me the whole distance or the whole measure of that entire angle is 135. The measure of angle L, M, V, the top one, is -1 plus 45x. The measure of angle V, M, N, the bottom one, is 23x. So what the angle addition postulate says is you two small ones must add up to the whole way across, which is 135. So I'm going to write that out. The top one plus the bottom one must equal the entire way across. Now I'll go use my algebra to solve this. The first thing I'm going to do is combine some like terms. I've got x's living on the same side with more x's. I'm going to combine those. I don't know why that changed color. It's possessed. I'm going to add 1 to both sides. 68x is equal to 136, right? And then I'm going to solve this for x by dividing both sides by 68. Bam, 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 bam. 136 divided by 68 is 2. I'm going to go back and revisit the question to make sure x is what I was supposed to find, and I was. If it said to find the measure of one of those angles, like if it said to find the measure of angle VMN, N, I'd plug it in, and I'd say, well, that's a 46-degree angle, but it didn't say to do that. So that's the end of this video. You will stop, and you will go work on worksheets 1.3, 1.4, and 1.5. When they're done, again, have me check off the video notes and the worksheet on your syllabus. Again, peace out. Have a good one. Carry on.